This is a map. It has one job: show where the land ends and the water begins. And most of the time, it performs that job with the confidence of something that has never met an earthquake. Because coastlines are not permanent. Rivers are not permanent. Apparently, even the ground underneath an entire city can become So today we are counting down 10 earthquakes that made existing maps physically wrong. I mean roads under the tide, forests turned into seabed, and one town being stored underneath a harbor for future archaeologists. Number 10. Lisbon, 1755. This is the medieval center of Lisbon. Narrow streets, crowded buildings, packed churches, and no plan for the Atlantic entering downtown. Then a massive offshore earthquake struck. Buildings collapsed, survivors moved toward the open waterfront, and the waterfront responded by sending in a tsunami. Fires then burned through what remained, because apparently the first two disasters had left unfinished business. The lower city could not simply be placed back where it was. Planners rebuilt the Baixa with a regular grid, wider roads, and early earthquake-resistant structural ideas. So Lisbon did not receive a new island or a new coastline. It received something almost as rare: city planners admitting the old design had failed. The earthquake erased one urban map and created the Lisbon layout people still walk through today. Number 9. Port Royal, 1692. This is Port Royal, Jamaica, one of the wealthiest colonial ports in the Caribbean. And this is the same commercial district after the Crown decided it would rather be part of Kingston Harbor. Port Royal had been built on loose, water-saturated sand. During the quake, liquefaction made the sand behave less like ground and more like fluid. Buildings tilted, streets broke apart, and large sections of the town sank beneath water and sand. Contemporary accounts described people trapped as the ground moved around them, and survivors forced to live in temporary huts. Underwater archaeologists later excavated submerged buildings, tools, organic material, and human remains in the former town center, which means Port Royal achieved something most cities can only dream of. It became a perfectly preserved historical district by making itself completely unusable. Number 8. New Madrid, 1811 to 1812. The next earthquake changed a map without going anywhere near an ocean. Major earthquakes struck the Mississippi Valley, collapsing banks, opening fissures, ejecting sand, and changing channels. You have probably heard that the Mississippi River ran backward. No, the entire river did not permanently reverse direction and begin a new life in Canada. Uplift, collapsing banks, temporary waterfalls, and earthquake-generated waves created short-lived upstream flow in some places. The permanent change was better. Land near the real foot fault dropped by roughly 1.5 to 6 meters in places, drainage was blocked, and a partly flooded forest became Real Foot Lake. River crews suddenly faced new rapids, sandbars, snags, and channels where their familiar route had been. The map was inaccurate in the much more exciting "your boat may now hit a treeway." Number 7. Kaikōura, 2016. This is the coast of New Zealand's South Island before November 14, 2016. And this is it afterward. If the second image looks like the tide forgot to return, that is because the seabed itself moved upward. The magnitude 7.8 quake ruptured more than 20 faults, triggered tens of thousands of landslides, and deformed around 110 kilometers of coast. Along one stretch, the seabed commonly rose about half a meter to 2 meters, with a local area lifted roughly 5.5 meters. Yesterday, it was marine habitat. Today, it was waterfront property with no water. Kelp, shellfish, and rocky reef were left exposed, while landslides cut the town off by road and rail. Residents and tourists spent the following days sharing shelter and supplies while aftershocks continued. So yes, the earthquake created new land. It just forgot to make the new land useful. Number 6. Lituya Bay, 1958. This number needs a sense of scale. A magnitude 7.8 earthquake triggered roughly 30 million cubic meters of rock and ice to collapse into Lituya Bay. The impact displaced the water and stripped trees from the opposite slope up to an elevation of 524 meters, or 1,720 feet. Important correction, that is run-up height, not a 524-meter wall of water traveling through the entire bay. The internet will survive this disappointment. Howard Ulrich and his 7-year-old son watched the disturbance form while anchored inside the bay. He could not free the anchor, release the chain, started the engine, and their boat was carried upward but survived. Another boat was thrown over a spit of land. A third sank with 2 people aboard. Lituya Bay was not an ocean-wide tsunami. It was a mountainside turning a narrow inlet into the world's least relaxing wave pool. Number 5. The Indian Ocean, 2004. Now the scale changes completely. The magnitude 9.1 Sumatra Andaman earthquake ruptured roughly 1,200 kilometers of plate boundary. Vertical movement of the seafloor displaced the water above it, producing a series of long waves that crossed the ocean and grew more destructive near shallow coastlines. Northern Sumatra was hit within minutes. Other countries had more time, but no operational basin-wide warning network. In some places, the sea withdrew so far that people walked onto the exposed seabed dead because they did not recognize the warning. The earthquake and tsunami killed or left missing more than 220,000 people across the region. It also physically lifted reefs, lowered parts of the coast, erased beaches, and changed shorelines around northern Sumatra and nearby islands. There is no joke for the human cost. The lasting payoff was a new Indian Ocean warning system built because an entire ocean had just demonstrated that distance is not protection. Number 4. Tōhoku, Japan, 2011. Japan had seawalls, sirens, hazard maps, drills, and one of the most advanced warning systems on Earth. The earthquake responded by becoming larger than many of those plans expected. The Tōhoku earthquake measured magnitude 9.0 in Japan's official account and 9.1 in the current USGS catalog. Parts of northeastern Honshu moved horizontally by meters, while coastal towns subsided by tens of centimeters and locally more than a meter. So before the water arrived, the coast had already lowered itself closer to the water. The tsunami reached some areas within about 30 minutes, overtopped defenses, erased neighborhoods, and contributed to the Fukushima Daiichi nuclear disaster. But preparation still mattered. Survivor Aki Kawasaki later said that students and teachers survived because they had practiced disaster preparedness together. Japan's rebuilt map now includes raised land, new evacuation structures, relocated housing, and communities moved farther from the coast. The defenses were not useless. They were simply reminded that geology does not read design specifications. Number 3. Chile, 1960. This is the largest earthquake ever measured with instruments, magnitude 9.5. The rupture extended for roughly 1,000 kilometers along southern Chile. Some coastal land rose, other areas sank, riverbanks spread, roads cracked, and lowered forests near the Rio Maullin became salt marsh. Landslides blocked the outlet of Rinyahu Lake, creating a second flood threat to Valdivia. Jose Argumedo was riding a horse when the shaking forced him to dismount. Cold War news had dominated the radio, so he initially believed nuclear war had begun. That sounds irrational until the ground moves for minutes and your horse gives up. Other residents escaped to high ground after recognizing the natural warning. Some returned for belongings or found bridges already destroyed. Chile did not experience one clean disaster. It experienced the coast, rivers, roads, hillsides, and ocean, all submitting separate edits to the same map. Number 2. Cascadia, 1700. This earthquake was so old that the affected coast had no seismographs and no surviving local written measurement. Unfortunately, the trees kept receipts. The magnitude 8.7 to 9.2 Cascadia earthquake caused parts of the Pacific Northwest coast to drop into tidal water. Saltwater killed forests whose tree rings date their deaths to the winter of 1699, 1700. Marshes preserve layers of dropped soil, tsunami sand, and later tidal mud. Japan recorded an orphan tsunami on January 27, 1700, flooding with no local Japanese earthquake to explain it. And indigenous oral histories describe violent nighttime shaking, flooding, destroyed villages, and the survival advantage of high ground. Put the evidence together and the invisible earthquake becomes readable. The coast sank, the wave crossed the Pacific, and two cultures on opposite sides of the ocean preserved different halves of the same event. So no, there was not an absence of records. The records were trees, mud, Japanese documents, and memory. Science just needed to learn how to read all four. The number 1 earthquake did almost everything on this list at once. The magnitude 9.2 Great Alaska Earthquake shook southern Alaska for almost 5 minutes. Across the affected region, some land rose as much as roughly 11.5 meters, while other areas dropped by about 2.4 meters. Near Portage, subsidence allowed salt water to enter forests that had grown safely above the tide. Sections of the Seward Highway became too low and had to be raised or relocated. In Anchorage, sensitive water-rich clay failed and carried parts of Turnagain Heights toward Nick Arm. In Chenega, the first wave reached the village before the shaking had fully stopped. Survivor accounts describe the community church cracking and breaking apart, while most of the settlement was destroyed. Alaska changed elevation, shorelines, roads, forests, neighborhoods, and harbors in one event. It is number 1 because the earthquake did not simply make the old map inaccurate. It made the basic idea of a stable map look slightly overconfident. The useful maps are the ones drawn with that instability in mind. Evacuation routes, high ground, unstable soil, expected subsidence, and roads that may not survive. Because solid ground is a comforting phrase. The planet has simply never agreed to it.